Hello, everybody. Welcome back. It's Mo again. So, what we're going to do in this section is focus on a Class C address. We know that a Class C falls into what range? 192 to what? 223. That's a Class C address, goes from 192 to 223. As long as the first octet falls in between 192 and 223, that's a Class C address. Now, why would I choose a Class C versus a B or an A? The beginning, we're looking at internal numbers, which is the LAN, which is my actual what? Private network. And we'll see the difference. There's private and there's public IPs. All right, so watch this. So if I have 192.168.100.1, my subnet mask was what? The default that I'm getting is 3255.0. So if I go back over here, watch this, and let's say I switch to DHCP, and I don't have a DHCP server, which is a pool of numbers that gets distributed to the clients, I'm going to get a failure, and we'll see what that is. All right, DHCP, and right over here, DHCP. So if I go back and say I want to give myself a static IP address, and I say 192.168.100.1, and I hit the tab key, I get 3255s. That's a Class C. The first three octets are 3255s, and we'll see why, which is really called my network portion, and the last one is the host portion. If I go ahead and I put, let's say, 192.168.100.0, I get a failure. It's not working. Okay. How about if I put 192.168.100.255? Check that out. It's failing. I only can go from 1 to 254. The first three octets for a Class C is the network portion, and the last octet is the host portion. What does that mean? How do I know that? Well, the default mask for a Class C is 3255.0. So I have 255.255.255.0. So it's 3255's dot and fractal 0. So if I go back right over here, I get 100, right? So most likely the Class C address is going to be 192.168.100.0/24. Why 24? Because that's my CIDR classless interdomain routing. My CIDR is a /24 3255.0. That's a given. That's a rule. That's what TCPIP is all about. Rules. It's a language that PCs use to talk to each other, right? So I cannot modify that. So what does that mean when the first three octets is the network portion and the last octet is the host portion, which means I cannot mess around with the first three numbers. I cannot put a zero, as you saw, because that represents my network ID. And I cannot put a 255, that represents the broadcast. Okay, so technically speaking, this is what I'm actually looking for. So I have 192.168.100.0, right? And then I'm going to put this, and you'll see why 100. See, the first three don't change 254. And then I get 100.255. So zero over here is called the network ID, which is what network do I belong to? I belong to the 192.168.100 network. Then I got 192.168.100.1 is actually my first host, which means any device that gets an IP address is considered a host. And the last host is what? 192.168.100.254. This is the last host. And then the broadcast is what over here? This is the broadcast. See that? Which means if I send a message to the broadcast, it goes to everybody. So I'm actually losing two numbers, the 0 and the 255. I cannot go over 255 because do you remember why? Yes. All right. So remember 128.64, 32.16.8.4.2.1. If I put all ones over here, what is the highest number that I get? Is a 255. And what is the lowest number that I get? Is an actual what? Is an actual 0. That's what I actually get over here. So my network tells me which network I'm on, and this is the broadcast. I only can use numbers from 1 to 254, and this is the default mask, and it's a /24 because I have 8 ones, 8 ones, 8 ones, 8 zeros. So if I go back over here, and let's say I go ahead and put 192.168.100.1, hit the tab key. See, 3255s. Then I go back over here and I put, let's say 192.168, 100 dot what? Let's say 100.2. Okay. And look, I don't need a default gateway. This is the IP address of the router for me to get online. DNS is for name resolution, so I'm not touching anything there, right? And let's say I put 100.3 and 100.4. So I could go from 1 to 254. I cannot put a 0. I cannot put a 255. 192.168.100.3 and 192.168.100.4. See that? So 1, 2, 3, and 4. So those are the numbers that I'm actually assigning. So I have 4 hosts. A host is any device that gets an IP address. I want to test communication. I want to test connectivity between all these actual computers. What I could do is if I open the laptop and go to command prompt, and let's run ipconfig. I can see my IP address. All right. And I want to go ahead and ping 192.168.100.2. If I get a reply, that means everything is good. So this is the ICMP packets, then 100.3. I'm hitting the up arrow, and then 100.4. So they all belong to the same network. That's what they belong to the same network, right? So if I type in help over here, I can see all the commands that I could run from the system right over here. So what I'm actually using right now is the ping. You see, that's how I actually see which commands can I run from the command prompt over here, as you see. So what I'm trying to say is I am actually on one network over here, which is what? The 192.168.100.0. So when I do ipconfig, let's say /all, right? I could see my IP address. I could see my subnet mask, what network I belong to, which means the first 3 octets should be the same on every computer for them to talk to each other. If not, I need a router to route from one network to another. Okay. For example, what do I mean by that? See, all of them, if I maneuver the mouse, 100.1/24, 100.2/24, 100.3/24, 100.4/24. So the first 3 octets is my network ID, and the last octet is the host ID, right? So that's one thing to keep in mind. So I have the network portion and I have the host portion. Cannot mess around with the first 3 octets. I cannot put a 0. That tells me what network I'm on. I cannot put a 255. That's a broadcast. So every network has a network ID and the broadcast. So you're losing 2 numbers. In other words, what I'm trying to say is this: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we know that the first 3 octets is the network. How do I prove that to you? Well, check this out. I'm going to go to this machine and go ahead and change the third octet to a 200. All right, watch this. And I'm going to go to this machine and change the third octet to a 200. See this? So what I'm trying to do is the following over here. This one is 100.1/24. This one is 100.2/24. See, these belong to the same network because the first 3 octets are the same. And this one is 200.3, different network. The first 3 octets are not matching. And look at this one. So these two belong to one network, and these two belong to a different network. So if I open the command prompt here, and I say, let me go ahead and clear the screen. Is it clear? Okay, they don't, and not all the commands are available. All right. So if I try to ping 192.168, let's say 200.3, I'm gonna get a timeout. It's like, hello, you cannot actually reach it. It's on a different network. You see that? There's no communication between them because my first 3 octets is 192.168.100, and I'm trying to reach 192.168.200. There's no way they can actually talk to each other, and it's failing. I could do Control C to stop it. Right? You see that? I could do Control C to stop it. And same thing with 4, I won't be able to reach. What does that tell me? The first 2 machines, they could talk to each other, and the last 2 machines, they can talk to each other. Why? Because of what? Because of the following. Look at the first 3 octets here: 192.168.100, 192.168.100. They could talk to each other. This is what? Oh, 192.168.200. And this one is 192.168.200. These two can talk to each other, and these two can talk to each other. So if I open this machine, it ping 192.168. Look at this. 200.4. Oh, there you go. I'm reaching it. The first 3 octets are actually the same. But can I reach, let's say, 100.1? No, it's a different network. You see that? So what does that tell me? Every network, if I'm using a class C and it's classful, which means we're not subnetting. We'll see what that is. This is default. I get how many hosts? From 1 to 254 for every network. So if I go back here, I get from 1 to 254. I cannot use a 0 as a network ID. I cannot use 255 as an IP, that's the broadcast. All right. What I'm trying to say is the following. I only have 8 bits for the host. What does that mean? 2 to the power of 8, and I always do -2. Why -2? Because I can't use a network ID and I cannot use a broadcast. What's 2 to the 8? 256 minus 2, which equals 254 hosts per a network. And I get from the number 1, the number what? 254. So if I have a class C, I only can get 254 hosts per a network for a class C address, right? So this is the one that gives you like the least hosts. And remember, the first 3 octets have to match on a class C for them to talk to each other. I could show you this right now. Instead of opening the command prompt and ping, watch this. See this envelope? These are ICMP packets. PDU, which is the protocol data unit. I move envelope here, envelope here. Successful. ICMP. Envelope here, envelope here. These two can talk to each other. These two can talk to each other. I put envelope here, envelope here. Look, it's failing, right? Let me delete. Again, envelope here and envelope here. It's failing. Again, envelope here and envelope here. It's failing. So instead of doing ping, I could just actually put the envelope, which is really ICMP in the background, and I'm trying to test it from one computer to what? To another. So that's one thing to keep in mind. So when we talk about TCP/IP and we talk about Class C, the first 3 octets are the network and the last octet is the host. So the first 3 have to match on each computer. If they don't, I could make them talk to each other, but I have to configure routing, which means connecting from one network to another. So this is what I wanted to show you about a Class C. And of course, another thing about a Class C, it's always a slash what? 24. So you have a slash 24 for a Class C address, 24 bits for the subnet mask, 24 bits for the network portion, and 8 bits for the host portion, all right? So remember the rules of Class C. And I know that this is a Class C because it starts with what? With 192. I want to show you something different right now. If I put these in 128, 64, 32, 16, 8, 4, 2, 1, and I put 1101, 1111. Look at this. If you want to remember the ranges, which is 192 to where? Look at this. Remember the range for Class C? 192 to 223. Watch this. Let me do the calculation over here. 128 plus 64 is what? 192. All right. 192 plus 16 is what? 208 plus 16, 220, 222, 223. So remember this format 110, then all ones. That means 192 to 223. That's how you could know the range of a Class C address. So this is 192 to 223. And we'll see, we'll do the same thing for Class B and Class A. I wanted to start with Class C because it's the easiest to look at. So remember, the first 3 octets is the network, and the last octet is the host. And this is a classful network, which means we're not actually subnetting, all right? So what I'm going to do is, when we continue with our next lecture, we're going to be looking at a Class B address. All right, so we'll see you folks in our next lecture. Bye now. Okay.